Hello everyone, it's Mr. Anderson again. I'm coming to you today with section 3.2.1 and we're going to reinvestigate using algebra tiles again how we can represent an equation. I'll invite you to recognize this representation web that we have up here. It is something that we saw in chapter 2 and we are going to focus on a couple of these things today, a couple of these connections that we've probably already created, but one more time, we are going to be using algebra tiles. I'm going to start off with problem 3-26 today, and because we're not in person, because we're delivering this at a distance, I'm going to move to problem B. And the directions or the prompt says, hey, build the collection of algebra tiles, then name the collection using the simplest algebraic expression that you can. Really, what this is saying is, will you combine like terms? That's what we're going to do. Now, I went ahead already prior to starting this video, and I did the building for us. So I'm going to show you that in just a second here, but let's start with this first problem because this is a pretty good problem to get our feet wet with, revisit that combining like terms idea, and then also reintroduce some algebra tiles. So we've got 3x plus 5 plus x squared plus y plus 2x squared plus 2 plus x. I see some students sometimes they'll do things like this. They'll say, okay, well this is a x, this is an x, those things are going to be able to go together, and they might use like circles, squares, triangles, however. The 5 is going to go together with this 2, right? We've got some like terms. I've got an x squared and an x squared, so those things are going to go together. All right, x squared and 2x squared. And then finally, you know, there's a y, and there's nothing really that's going to go with that y because I don't have anything else, so I'll just put that in its own color. But when we use algebra tiles, we can see this as well. I've got this set up, 3x plus 5 plus x squared plus y plus 2x squared plus 2 plus x. And really, when we are combining like terms, what exactly is happening? Well, I'm going to take these things that match and I'm going to put them together. Now, I'm taking the x squareds and I'm starting there because of an idea that's probably going to come up later. I'm going to put the x squareds together. First of all, we usually write these things in alphabetical order. We also write the highest degree first, and because an x squared has a higher degree than just an x, I'll put that one first. If you didn't, it's not a big deal. But the x squareds are going to get written down first. I'm going to take these, I'm going to put them together over here because those shapes match, and I'll try to line those up nicely. There we go. Okay, and then I've got some x's. I'm going to slide this y down. All right, I'll take these x's and I'll just put them right here next to this one, and take this one and put it right down here. And then I've got a y, and then I've got some unit tiles. Okay, now what do we really have? I've got 1, 2, 3 x squareds, 1, 2, 3, 4 x's. I've got a y, and I've got 1, 2, 3, 4, 5, 6, 7 unit tiles. And that checks out, right? If you guys go ahead and take the x squared and the 2x squared, we get 3x squared. Maybe you like to cross these things out. Then I take the 3x and the x, I put it, okay, 4x, all right. And now I'll put that y on there, and if you wrote these in a different order, and I'm sorry, I'm not crossing them out. If you wrote these in a different order, that's no big deal. And then finally, 5 and 2 make 7. And there you go. You've got that thing in, as simple as it can possibly be, right? I'm not putting together the x's with the x squared because they're not the like terms. And if you need confirmation of that, check out the shapes we got going here. All right, next problem is going to be maybe a little bit more interesting. Double I over here, I've got 3y plus 2 plus 2xy plus 4 plus y squared plus y, plus 4y plus 1. And I went ahead and built this as well. So one more time, I'm going to use these CPME algebra tiles, and I can start with the y squared. I'm looking already, and I can see that these things are going to go together. And then I've got some XYs. Gosh, there's no other green shapes that look like this. Okay, so I'll start here. I'll do a little like dragging and rearranging, and then I'll do some rewriting. Okay, I'll put those for space's sake right there. I do like to write these things in alphabetical order, so I'll put the x's first. I don't have an x squared here. Then I'll put the xy up there. Notice this, I mean, it matches this dimension, but it's not the same shape. So it's kind of got to be on its own now. And then I've got some y's coming along. And then, oh, there's some unit tiles. Okay, check that out. All right. I don't have any shapes that match in size or in color, so I really can't do any more combining. I'm sorry, size and in color. My bad, size and color. So what do we got? We got 1, 2, 3, 4 x's. I got 2xy. I've got y squared. I've got 1, 2, 3, 4, 5, 6, 7 y's, and then I've got a 1, 2, 3 unit tile measurement. So I can go ahead and I'm just going to write this down. 4 x's plus 2xy plus y squared plus 7y plus 3. And ladies and gents, you can confirm that that does check out and that will balance, okay? We're going to keep on keeping on. We're going to keep using these algebra tiles to do a couple of cool things algebraically. The next problem I'm going to move on to is number 27. And I've got a screenshot of what I took from the book right here. So I'm not going to build these shapes because I already have them built, but I'm not going to build or sketch because, like I said, they're already here. But I am going to set the stage for some new learning by talking about perimeter and area. And this is actually pretty gosh darn manageable. I'll start with A. And A, I'm going to just make a note here. The area is going to be how much space this thing covers. And we use the names of these tiles to do that. I know there's not a name in there, but we'll do that in just a moment. I've got a y squared. I've got an x squared. And that little itty bitty guy right there, that's just a 1. That's a unit tile. So my area is going to be x squared plus y squared plus 1. And you know what? I just went from left to right. The last one I wrote in alphabetical order. I can do the exact same thing here. If you didn't change that, it's no big deal. Okay? The perimeter is going to be slightly different, and I'm going to just do that in an alternate color so it stands out. Okay? The perimeter is going to look, like I said, slightly different. Remember, if this is a y squared tile, it's got dimensions of y and y and y. This right here is going to be a y, but I've got an x squared covering that up, so that's going to be a little bit different. This is going to be an x and an x. I've got 1, 1, and 1, and then this would be an x as well. So how is this going to work out in terms of the perimeter? I got to get rid of these for something we're about to do here. All right, this right here, this distance right here would be y, but I've got x of it covered up. So believe it or not, that thing right there is y minus x. Likewise, this thing, I got to draw an arrow to it, this thing would be x, but I got one of them covered up, so it's going to be x minus 1. And now what I can do is I can go ahead and start to assemble these things for that perimeter. I've got y and y and y, and then I've got x and x, and then I've got 1 and 1, and I'm going to kind of slide this up here. I've got 1 and 1 and 1, and then I've got an x minus 1, and then finally I've got a y minus x. Now right now that doesn't look like much, but I can go ahead and I can start to assemble these like terms, all right? I'm not going to build this using this expression using algebra tiles, but what I am going to do is maybe a method that some of you recognize. I've got x, 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 and then negative x. So 3 x's when I put them together, that is going to be 3x, but then I take away an x, I've got 2x. And then next I'm going to have, let's see, I've got a y, I've got a y, I've got another y, and then I've got a y right there. Okay, so that works out to be 4y. And then finally, and I think this is going to take care of everything, I've got a 1, I've got a 1, I've got a 1, and then I've got a negative 1. I've got 1, 2, 3, and I'm taking 1 away, so that looks like it's going to work out to be, oops, it looks like it's going to work out to be 2. Okay, so there is my perimeter for this shape. All right, I'm going to go ahead and I'm going to leave that one on the screen. Pause it if you need to take anything from it. B, I'm not going to cover. All right, if you want to tackle B, B would be some excellent practice. I promise A is, I think, the more difficult one in terms of the covering up and the subtraction that we've got going on there. But ladies and gents, I'm going to show you one more thing in this video. I'm going to talk a little review preview, and then we're going to be done. All right, this right here says, using algebra tiles and an equation mat, create the physical representation of this equation and then use your legal moves to solve. So I'm going to go ahead here and I set up an equation mat ahead of time, and I'm going to just build this on our what's it called, equation mat, and then I'm going to simplify using, like I said, those legal moves. All right, I've got a negative x, and then I've got negative 3. 1, 2, 3, and those are negatives, sorry. I'm just trying to change the sign. Negative 3, and then I'm taking away 1 plus x. So I'm going to take away the quantity of 1 plus, I'm sorry, negative x. All right, so that's going to look like this. And then on the other side, I've got negative x, and then positive 2. So I just throw those up here. And then finally, I'm taking away the quantity of 2x plus negative x. So I'm going to take, I'm going to take away the quantity of 2x, let's see, plus negative x. Okay, so here's how this is going to set up. So I've got it built. Now I'm going to remind you of some of these legal moves, and then we'll do some solving, okay? So here we go. Legal move number 1. Let's take everything from the bottom and change it to the top, but to do so, we've got to flip the signs. All right? Bottom to top, change those signs. There we go. And then finally, once that's all done, we can go ahead and start doing some canceling. Get rid of some of these 0 pairs. Okay, those things are opposite pairs. They can cancel. These things are opposite pairs. They can cancel. Look at how quick this simplification is going. Next thing I can go ahead and do is I can start to cancel things that are the exact same across that equal sign. So if I've got negative tiles over here, negative unit tiles, which I don't, I could cancel. If I had positive unit tiles over here, which I don't, I could cancel. So then what I'm going to do is I'm going to start to drag some things across, and I can reverse that sign. Okay, check this out. Okay, so what I have now is I have the expression 2x equals 1, 2, 3, 4, 5, 6. Interesting. Now I'm going to kind of split this into 2 piles here and get rid of a repeat, and I think you guys are going to see what works out pretty nicely. What does x have to be? X has to be 1, 2, 3. All right, and that, ladies and gents, is the solution to our equation. I promise, if you went ahead and checked that thing out, you'd find that x does equal 3. All right, a little bit of review preview. Just 4 problems, 34, 35, 36, and then 38. Ladies and gents, thanks for watching. Have a great day.